Okay, so again, good morning class. Last meeting we discussed yung pagde-design of isolated footing with uniform pressure or under actually loaded footing. Okay, so you determine yung required area given the QE. Okay, yung isa-solve yung effective soil pressure. Then also you determine the one-way and two-way shear, and also the moment, the flexure or the bending on the foundation, and also determine the number of bars required. Okay, so today we will discuss naman what is an isolated footing subjected naman siya with axial and bending. Okay, so in the summary of actually loaded footing, so we have your assumed conditions, which is uniform pressure below. Okay, the area required, which is QE from the dead load, live load, and effective cell pressure. The one-way shear, which is equivalent to this one. Okay, should be less than or equal to the capacity of your concrete, which is 0.17 lambda squared of F prime C. Okay, whereas your VU sub W is comes from the assumption that your soil pressure is rectangular below or uniform in pressure. Okay, di ba? And also, we have your two-way shear or the punching shear. And the same assumption, your VU sub P comes from the uniform pressure below. And your actual your demand, what you call this, your demand punching shear stress is equivalent to this equation, and your capacity is the least of this equation. So we have a size modification factor uh, in ACI 2019. So just remove that size modification factor when you are designing under the NCP 2015. And also, you have different values of alpha of your alpha S depends if your column is interior, the column is in exterior, or in the corners. Okay. Then for the bending, we have this assumption: cantilever strip with uh, a uniform pressure again. Okay. And when you lay out your reinforcement when you are dealing with rectangular footing. So ito yung tinatawag na bandwidth, okay, yung the reinforcement in the bandwidth. Okay? So what if the isolated footing have moments? So kung pag may moments ba, the same pa rin ba ng assumption na you have your uniform pressure below? Okay? So hindi. So an isolated footing with an axial or a single axis bending, okay, and a single axis bending, meaning meron siyang axial load with bending. Okay? So ito single axis lang. So bending can be in x axis or your bending can be in the y axis. Okay? So ito yung itsura niya dito. Yan. So ito pwede tong nandito sa taas. Okay? And wala to. So pwede yun to. Basta bending in the y-axis only. Okay. Sorry, bending in the single axis only. So either anong side, it doesn't matter. Okay. So the same solution to the actually loaded footing except for the assumption of the pressure at the soil. So ibig sabihin lahat ng theories ng one-way shear, ng punching shear, ng required area, ng moment is the same except for the assumption of your pressure at the soil. So if we recall that in actually loaded footing, yung assumption dun sa load ng soil is, di ba ganito? P times B over L. Di ba? Or if you recall, yung QU is equals to PU over area, just like this one, di ba? So basically, that is P over B times L. So I just use the sign this time. Yung negative means compression. And since we all know that your force or your axial load is in compression. So that is why your Q is equals to negative P over B times L. So yan yung sa actually loaded footing. So in the case naman, yung footing mo with axial and bending, so single axis bending lang to, yung actual soil pressure mo is the sum of the pressure due to your axial, okay, sorry, should be axial. So bakit ito yung naka-highlight? It should be the contribution of the axial and the bending. Okay, this one is a contribution of your axial and due to bending. Okay, so ano ba yung soil pressure due to the bending? So alam niyo natin axial, that is negative P divided by B over B times L, which is force over area. So ano naman yung sa bending? Sa bending is basically your flexural stress. Flexural stress or bending stress. So if you recall yung by strength of materials, the formula for the flexural stress is just basically MC over I. Okay, so moment, central distance, inertia. Okay, that is yung flexural stress. So if we change your MC over I to in terms of section modulus, so we have Q is equals to negative P over B of B times L plus or minus moment over the section modulus. So we have a plus and minus, okay, because meron tayong active tension side and meron tayong compression side. So saan yung active side and compression side na yon? So ito yung pressure diagram in a single axis bending. Ito yung assumption doon. Okay? So saan sa tingin nyo dito meron, kung ganito yung moment, saan sa tingin nyo dito yung okay. So it should be, kapag ganyan, dito tayo tumingin. So this is L. Tama? Kasi for ganyan, ito yung moment. So dito tayo tumingin. Okay. And that is your L. Okay, so L yung ibig sabihin na yun. Okay. So, kung ganito yung ating moment, saan sa tingin nyo dito yung may pressure, compression and yung pressure na tension? Okay. So, tama ba na yung, kapag ganyan yung moment, yung mangyayari sa footing mo is maybe exaggerated? Okay, ganito. Tama ba? Nagigets nyo? Nakikita nyo ba? Na ganyan yung mangyayari doon sa footing nyo? Kapag ganyan yung moment. Okay, so kapag sa kabila naman yung moment, let's say pag ganito, so babaliktad naman siya, di ba? Okay. So for if your moment is like this, okay, so this part is in compression. Okay. And this part is in tension. Okay? So yung part na to magpe-press dun sa soil. So kaya siya compression. Okay? Didiinan niyo yung soil. And yung itong part na to is tends going away from the soil. So therefore, it siya ay tension. Okay? So yan yung compression and tension part of your pressure diagram. Siyempre, 'di ba, your equation is negative P over B times L, which is in compression. And itong part na to is either compression or tension. Okay? So this part syempre, ito yung compression and tension, both compression. Okay, wait lang. Okay. So this part is yung both compression because the compression due to the axial load, okay, due to axial and due to compression moment. Okay, so both mag-a-add. So basically, sign lang natin yung isama. So negative yung axial, then negative yung compression, yung bending in compression. Then itong part na to, ito yung mas mababa, which is yung negative yung axial, and positive naman yung M over S, or yung bending in tension. So kung ilalagay natin yung equation, itong part na to is negative P over B times L minus M over S. And then yung itong part na to is negative P or B times L plus M over S. Okay? So do you have questions, class? Okay. So ano sa tingin niyo yung itsura nung yung diagram sa ilalim? Tama ba na para siyang trapezoidal prism? Trapezoidal prism. So let's say for ganyan, so pwede siyang ganyan. Then doon sa kabila, ito. Yan, para siyang trapezoidal. Yan, trapezoidal prism. Yan, pababa. Okay. Should be dapat mas mababa pa. No? So parang ganito siya, mas mababa. Okay, so ito natin ilagay. Yan. Tapos yan. Okay. So yan yung pressure dun sa ilalim. Okay. So ganyan yung itsura ng pressure diagram kapag meron kang actually loaded with single axis bending. Okay? So mas maganda siguro if we try to solve for a problem. Okay? So this one is example problem for actually loaded with single axis bending. So it is from the book of Structural Engineering by Besavilla. Okay. So yung 300 millimeter square column is supported by a 2.2 by 0.9 meters rectangular column. Okay. Your F prime C is 27.6 MPa. Your Fy is 414.17 so 414.7 MPa, and the effective depth of the footing is 300 millimeters. Okay. The question is, your allowable soil pressure is 240 MPa. Okay. So, you have your column loads, okay, which is the actual loads is yung PD, which is in dead load, is 220. And yung isa naman is PL, which is 137. And your moments are 10, 16, and 8 from dead load, live load, and earthquake. Okay, and also we have given yung two load combinations. Okay, yung this load combinations, kung papansin nyo, comes from the NSCP 2001. Okay, yung load combination 1 is 1.3 dead load plus 1.1 live load plus 1.1 earthquake, and your U is 1.4 dead load plus 1.7 live load. So if you have if you're wondering para saan ba yung load combinations, okay, yung load combinations class is ito yung maximum possible, or yung mga possible hindi siya maximum hindi sila lahat maximum. Okay, ito yung possible na pwedeng mangyari sa inyong building. Okay, possible na scenarios in your structure. So pwedeng ito yung load combination, or pwedeng ito yung mag-load combination, depends kapag sino yung mag-govern. Okay? So the question is, what is the ultimate bearing shear stress, ultimate beam shear stress pala, the ultimate punching shear stress, and the design moment along the long direction. Okay? So, yan. So maybe sagutan na lang natin siya separate. Sagutan natin separate. Okay. So, ayan. Nakikita niyo na ba yung screen? The whiteboard. Okay. So, let's try. Yung first problem is determine the ultimate bearing shear stress. Okay. So, number one, dito na lang natin nilagay. So, dito na. Okay, number one is, what is the ultimate beam shear stress? So, ultimate beam shear stress. So, what is ultimate beam shear stress? Di ba, siya rin yung one-way shear. Okay. Siya rin yung one-way shear stress. Okay. So, mas maganda siguro sa taas. Yan. So, siya rin yung one-way shear stress. Okay, so before we start, kailangan natin malaman yung governing loads and syempre kung ano yung pressure doon sa soil natin. Okay, before tayo mag-start for the ultimate beam shear stress. Kasi 'di ba, if you recall, doon sa pagde-design natin sa actually loaded, yung lahat ng VU, yung shear stress natin is comes from VU sub W, di ba? And your VU sub W comes from your soil pressure, actual soil pressure multiplied by nung shearing area. Yung contact area dun sa ilalim. So ganito rin yung gagawin natin dito. So kailangan muna natin malaman yung actual soil pressure. So, di ba yung actual soil pressure is equals to P over A plus your MC over I or yung M over SX. Okay. So, first, kailangan muna nating malaman yung tawag dito yung ultimate load, yung P sub U. Okay. So, asan yung ating P sub U? Yan. So, okay. So, before we start pala, kailangan muna nating i-check if your actual soil pressure in unfactored loads ay pasado dun sa allowable soil pressure in 240 MPa. So, your unfactored loads, which is the 220 plus 137, ito yung total total actual load. So maybe ilagay ko na lang yung negative sign para hindi kayo malito. Okay, para sa negative compression. Then also, your area, which is 2.2 by 0.9. So minus din. So pipiliin natin yung mas malaking maximum pressure. So should be both negative. Okay, then what are your moments? Your moments are 10. Okay, ipapag-add lang natin sila. 10 plus 16 plus 8. So 10 plus 16 plus 8. Then, what is your centroidal distance? Okay? So, kung magkakaroon kayo ng ganito, so let's say ito siya, diba? This is your 2.2 meters and this is your 0.9 meters. This is your column. Okay? So, based on the drawing, okay, based on the drawing like this one, so yung MU nyo is on the y-axis, tama ba? So, ibig sabihin, yung MU nyo, okay, yung MU natin is located, this one. Oops. Wala paano gagawin yung kulay niya. Okay. So, ganyan yung MU nyo. Okay. And kapag ganyan yung bending nyo, nakaganyan yung bending nyo. So, para din siyang nag-a-analyze kayo ng beam. Okay. So, pag nag-a-analyze tayo ng beam, di ba? Ito yung beam natin. So, ito yung beam natin. Let's say cantilever beam. Yan, cantilever beam. Then, you have a bending, okay, bending ka dito, which is Ayan. Okay. So, bending ka dyan. So, para magkaroon ka ng point load dito, P. So, para pag tinignan mo siya, guys, parang ganito siya. May bending ka dito and may P ka dito. Okay. So, kapag yung bending na yan dyan is will cause uh, maybe it will cause your cantilever na pupunta dito. Tama? So, tingnan natin if magkokontrahan sila ng load due to P. Okay? So, kapag ganyan yung bending, 'di ba? Ang ginagamit yung section modulus is from this bending, from ito. So, ito siya yung bending natin. This one and this one. So, ito yung BH cube over 12 mo. Diba? Ito yung B mo, ito yung H mo. Okay? So just like the same dun sa footing. Okay? So imagine yung depth of the footing is the length L. Okay? Imagine your depth of the footing is your length L. And itong 2.2 and 0.9 are the B and H of your footing or your dimensions. Sila yung B and H. Okay, di ba ganun yan? So, imagine mo, extrude mo tong, pull mo tong yung figure na to. And try to apply a moment along the Y. So, kapag in-extrude mo siya, so para siyang box, di ba? Pag in-extrude mo yan away from your monitor, so para siyang box. Pero yung box na yon, yung extrusion na yan is hanggang depth D lang. Hanggang effective depth lang. Then after that, point your right finger on the y-axis. Okay, right thumb. Okay, point mo yung right thumb mo on the y-axis and curl your yung four fingers mo, i-curl mo. Okay, so kapag ginanyan mo, okay, ito yung moment mo doon. Ito yung moment in Y. Okay, so ilagay mo yung palm mo na yan doon sa face nung sa extrusion mo, then curl mo siya ng ganyan. So what do you think will happen? So ang mangyayari sa kanya is, ito kunwari siya, di ba? Okay, ganyan siya kunwari. Yan. Ang mangyayari sa kanya, kapag kinurl mo siya on that side, okay. Okay. Pag kinurl natin siya, magkakaroon niya ng parang, paano ko ba siya i-draw? Okay, parang gantong bending. Okay. Tama. Ayan, just like this one. Okay. So parang ganyang bending siya kapag kinurl mo. Okay. So kapag ganyang bending, saan yung stability? Okay. Saan yung stability? Tama ba na kapag ganyan yung bending, yung stability mo is in this direction. And magki-curl yung dalawang sides, di ba? Okay. So ganyan yung stability mo. Kapag ganyan yung stability mo, nasan dito yung sino dito yung sino dito yung mag-cube or sino dito yung magre-remain, di ba? BH cube over 12. So kung saan yung stability mo, okay? So parallel to your stability, siya yung mag-cube. So which is, therefore your inertia is 2.2 cube times 0.9 divided by 12. So the same lang din siya dito in the case of cantilever beam. Pag ganito yung load, so ito yung magbe-bend. Okay, so kapag ganyan yung load, okay, so in y-axis na natin siya, ilagay na natin siya in y-axis. So ito ay my. Okay. So ito, let's say this one is your y, this is your x, and this is your z. Okay. Nilagay na natin siya sa my. So what will happen in the beam is magbe-bend siya ng ganito. Okay, ng ganito. Okay, ibang color. Mas maganda ibang color. Okay, mag-bend siya ng this one and this one. Okay, pati sa ilalim. Okay, pati sa isang sides. Yan. So magbe-bend siya ng ganyan. And di ba pag ganyan, ang ginagamit mong inertia dyan is the IY, which is equals to the B cube H over 12, which is the same. Kung saan yung may stability mo, okay. So, ganun na lang siya para hindi kayo malito. Kung nasaan yung stability, dun yung i-cube nyo. So, kapag nandito naman yung moment, ang stability ay nandito. So, therefore, yung i-cube mo ay yung 0.9. Okay. So, do you have questions for that? Okay. So, therefore, your so pwede ko nang gawin na inertia, which is the MC over I. So, ang gagawin ko, okay, so ang gagawin ko dito, so yung C ko ay si 2.2 over 1. Tama? Siya yung stability ko di ba? Siya yung length of my stability. So, therefore, siya yung kakalahati divided by the BH cube over 12. Or, sorry, the B cube H over 12, yung inertia, which is equals to 2.2 cube times 0.9 divided by 12. Okay, if we check, that is negative 227.13 kPa, which is also less than 240 kPa. Okay, so ibig sabihin yung area natin is okay. So after that, we can now check the actual soil pressure. So yung actual soil pressure natin, so we need to use your load combination. Okay. So kunin natin yung load combination for axial. Sabi niya dito, that is 1.3 plus 1.1 plus 1.1 E or 1.4 plus 1.7. Okay. Check muna natin yung load combinations 1 on both factors. So load combination 1, that is 1.3 dead load plus the 1.1 earthquake live load, sorry, plus the 1.1 earthquake. Okay. So for the PU in axial, that is equals to 1.3 times 230 plus the 1.1 times the L, which is 137, plus the 1.1 times 0, which is equivalent to, ano ba to? So 449.7, okay? And for the MU, using that load combination, so 1.3 times 10, okay? Then 1.1 times 16 plus the 1.1 times 8, which is equivalent to 39.4 kilonewton meter. Okay, so this is for U1. Okay, for U2, check natin yung U2. Your PU is equals to 1.4 dead load plus 1.7 live load. And therefore, okay, therefore your U2 is for your PU, that is 1.4 times our dead load 220 plus the 1.7 times the 137. Therefore, we get your PU, which is 540.9. And your MU, which is 1.4 dead load also plus the 1.7 live load, that is equals to 1.4 times 10 plus the 1.7 times 16, which is equivalent to 41.2 kilonewton meter. Okay, so obviously, okay, it is very obvious that your load combination 2 will govern because your PU is mas malaki doon and yung MU nyo is mas malaki rin dito. Okay, so therefore, your U2 will govern. Okay, very obvious na U2 will govern. However, kapag magkaiba yan, okay, so you will check both load combination. Check mo yung both load combination and you will arrive kung sino yung mas malakas na, mas mataas na load combination na mag-convert. Okay, and also, meron tayong tinatawag na enveloping. For enveloping, you will use the maximum PU for all load combination, and your your MU is the max for all load combination. Okay, for all load combo. So you can use enveloping, and yung isang way is depends on the load combination itself. So kung ano yung load combination lang ngayon, yun lang yung magbibigay ng maximum. Okay. So ibig sabihin yung enveloping is basically very conservative. Okay, so since lahat ng maximum sa PU, maximum sa MU yung gagamitin nyo. Okay. So I will state in the problem kung gagamit kayo ng enveloping or just simply take the maximum, take the governing load combinations. Okay. So ayan yung gagamitin natin. So therefore, your actual soil pressure, which is the QU, okay, yung QU natin, we have QU max and QU min, di ba? So for the QU max, ito yung mag-a-add yung dalawa, which is negative P over A. Okay. So nilagyan ko lang ng U for ultimate and your M over S. Okay. So kapag rectangular, you can just simply memorize this one. Negative PU over A, then your 6M over BD squared, or yung 6MU over your D squared. Okay? So itong BD squared is hindi yan always BD squared. So depende yan kung saan yung stability nyo. Baka ang gamitin nyo is BD squared na lang palagi, or BL squared na lang palagi. Okay? Baka malito kayo sa DS. So pagawin ko na lang yung D. So mas maganda siguro kung ibang notation. So B BL squared. Ayan, so ibang notation na lang. Okay, so let's try for the QU max. For the QU max, so negative 540.9 over the area, which is the 2.2 by 0.9. Then for the MU, so both negative for the QU max, that is 6 times the moment 41.2. So the question is, saan siya yung mag-i-squared, di ba? So katulad ng ginawa natin kanina, ito, 2.2 cube plus times 0.9 over 12, 2.2 over 1. Okay. So ganun lang din siya, di ba? Kasi let's say for example, your D over 2, okay, this is your MC over I, and yung isa is BD cube over 12. So kapag pag inano mo siya, kapag sinimplify mo, yung D makakancel, magiging squared, and yung 12 over 2 magiging 6. So therefore 6M over BD squared. Okay. So just check sino yung okay, so ibig sabihin, kailangan mo na i-check sino yung may stability, kung nasan yung stability, and siya yung siya yung naka-squared dito sa formula na to. So ito yung moment natin, ito yung stability natin. Therefore yung mag-i-square is the 2.2. Okay, right? So therefore you have your 0.9 by 2.2 squared. So if you check that, that is your 329.93 kPa. So ito yung ating okay. So yan yung maximum soil pressure dun sa isang side. Ito. Okay. So kung yung ganyan yung moment, ito yung pressure dito sa side na to. Okay, dito sa side na to. So both sila ay magko-compression. Okay. Then for the QU mean, okay, for the QU mean, UU mean is equals to negative PU over A. Add mo naman yung 6MU over BL squared. So that is negative 540.9, okay, 2.2, 0.9 plus the 6 times 41.2 over 0.9 by 2.2 squared. So therefore, you get your 216.43 kPa. Okay? So yan yung ating actual soil pressure. So kunin ko lang yung figure dun sa kabila. Okay? So therefore, ito yung ating figure. Yan. So ito siya, di ba? Ito yung pressure doon, which is ano nga to? Your 329.93. Ito siya. I-zoom in natin dito. Yan. Okay. Siya yung 329.93. And itong isa is yung 216.43. And this one and this one. Okay. So just like what we did in, sinabi ko nga, just like what we did in the one-way shear, okay, yung critical area is a D distance from the face of your column. And sinabi ko rin na ang may according to the problem, sabi sa problem is the ultimate beam shear stress. Okay. So therefore, kung ganyan yung soil pressure natin, so kunin mo lang yung area dito, 'di ba? Kunin mo yung area dito, 'di ba? If you recall, ang ginawa natin diyan yung VU sub W natin is kunin mo yung QU, multiply mo sa area na to. However, this time, iba yung pressure sa ilalim. Iba yung pressure sa ilalim, 'di ba? Ang pressure sa ilalim is trapezoidal. Okay, the trapezoidal yung pressure sa ilalim is 1. So therefore, you need to determine the area of your trapezoid, di ba? Pag kunuha mo yung area of the trapezoid, then get the volume, then multiplied by the pressure, okay, you will get your one-way shear force. Okay, di ba? So also, ganun din gagawin natin dito. Okay? So, kunin muna natin yung distance. So, ito yung mga distance niya. So, 0.65 and 1.55. Okay. So, meron tayong, pwede mong gawin dyan, pwede kang mag linear interpolation. Okay. So, paano magli-linear interpolation? So, at x equals to 0, okay, at x equals to 0, you have, sige, dito na lang tayo sa 1. Okay, kasi kailangan natin makuha yung 1.55 eh. So, pwede mong gawin at x equals to 0. Okay. Okay, dito yung x, ito yung y. Okay, x equals to 0, your value is 216.43. So, ito yung x na, ito yung 0 natin, di ba? So, then at isa pang point at x equals to 2.2, your y, which is the pressure, is 329.93. Then, by linear interpolation, find 1.55 meters, you will get your 296. So 1.55 y hat, you get your 296.4. Okay, so get your calculator. I will show you paano natin gagawin yan. 991 ES. Wala akong 991 ES. Open ko lang yung calculator ko para mapakita ko sa inyo yung paano. But pwede nyo nang pwede na kayong mag linear interpolation. Okay. Nakikita niyo yung screen, yung calculator ko.
Opo, sir.
Okay. So punta ka lang kayo ng mode and stat. Okay, let's choose one. Okay, dapat yung may may. So 3 stat a plus bx, x and y. So yung a plus bx na yan is simply yung linear equation, di ba? So at x equals to 0, your value is 216.43. Then at x equals to 2.2, your value is 329.93. So just click AC, then shift stat, shift 1, you get your regression. Then ang kailangan mo kunin is y values, di ba? So therefore, you get your y hat. Then ano yung gusto mong this length is the 1.55. Okay, the 1.55. Therefore, you get 296.40 kPa. So ganyan yung mag-linear interpolation. So pwedeng ganyan or yung linear interpolation na manual. Okay, doesn't matter. Okay, so therefore you get your. Okay, may question.
Sir, paano mag-ano sa sir? F789 SGA, sir. Wala po kasi sa 1 eh.
Actually hindi ko alam eh. Maybe you can explore and also di ba nakapag-stat ka ba?
Opo, sir. Pero hindi pa yung ganito gamit ko, sir.
Okay, siguro try mo yung hanapin mo yung function ng mga stat diyan. Hindi ka siya familiar eh. So kung hindi, mag manual computation. So paano yung manual? Ganito ang manual.
Yes, sir. Thank you po.
Okay. For the manual, so insert mo lang saan dito yung inyong values. So yung 1.55 yung kailangan mo, di ba? So 0 to 16.43. Then your 1.55 which is then unknown. So lagay natin x. Then yung isa 2.2, 329, 329.93. So basically, gatuhin nyo lang. Okay? So 0 minus 1.55 over yung sa ilalim, 216.43 minus x. Then yung isa, 0 minus 2.2. So 0 minus 2.2. Then 216 minus 329.93. Okay, then shift solve for x, you will arrive for the same values which is 296.40. Okay, so pwedeng ganito. Or gusto nyo mas mabilis, ilagay nyo siya sa taas. Ilagay nyo ito sa baba. Mas mabilis mag-shift solve kasi kapag nasa numerator yung unknown eh. Pwede rin yan. Okay. Mas mabilis kasi mag-solve if nasa taas yung numerator. Again, you will also arrive for the value of x equals to 96.4. Okay? Sige. So nakuha na natin yung value na 296.4 dito sa distance na to. Okay? So therefore, we can now solve for the actual soil pressure. So paano ba solve yun? So basically, kunin mo lang yung area of the trapezoid multiplied by the length 0.9. Okay? You will arrive for the soil pressure. Okay. So sige, kunin natin. Okay, so ang gagawin natin for the PU sub W, basically that is the volume of the soil pressure. Di ba ito yung may contact? So ito yung contact. So kailangan mo kunin yung area ng trapezoid. Okay, so paano ba kukunin yung area ng trapezoid? Di ba that is yung average height or yung mid height nila. So average height nila, so 296.4 plus 329.93 divided by 2. Or basically yan yung sa formula na B1 plus B2 Okay, over 2 times height. Okay, ito yung over 2. So ito yung yung mid height. Ito yung, ang kinocompute kasi doon class is yung mid height. Okay. Ito yung kinocompute doon, yung mid height na to. Then yung mid height na yan, yung i-multiply doon sa along the length para makuha yung volume. Okay. So yan yung mid height. Okay. So yan yung mid height natin. Multiplied mo by the distance 0.65. Okay. So you get your area multiplied by the length 0.9. Okay. So ito and ito. Okay. So ito, this one and this one. Okay. Therefore, your VU sub W is equivalent to 183.20 kilonewton. And therefore, your tau sub W, sorry, your tau sub W is basically your VU W over phi B times D, okay, which is equals to 183.20 times 10 raised to 3 for MPa. Your phi is 0.85. Okay, hindi ko siya nasabi. Yung phi natin is 0.85. Okay, because we are using the NSCP 2001 load combination. Okay, and your B is 0.9 and your D is 0.3. Okay, so gawin ko na lang siyang Newton millimeter squared. So para maging MPa, so it should be Newton millimeter squared. So ito ay 900 and 300. Okay, you get your value to be 0.8 MPa. Okay, so if you check that to your to the maximum capacity, which is less than or equal to 0.17 square root of f prime c. Okay, ano ba yung 0.17 square root of 20? Ang square root of 20 point, ano ba f prime c natin? 27.6. Okay. So 27.6 you get, which is equals to 0.88. So therefore, okay. Okay, so that is how you solve for the maximum shear stress. Okay, ito siya. Or the one-way shear stress. Okay. So do you have questions? Okay. So next natin is number 2, determine the, okay, lumalaki kapag malayo naka-zoom out. So number 2. Ang question natin sa number 2 is determine the ultimate punching shear stress. Okay, so this time, kailangan na natin solve yung ultimate punching shear stress. Okay, the ultimate punching shear stress. Okay, so just like what we did, okay, so di ba no need to solve na since alam na natin yung soil pressure sa ilalim. So ganito na lang gagawin natin doon. Drawing nyo na lang. So drawing nyo na siya. Okay. So ito daw, di ba ang punching shear stress is D over 2 distance from the face of the column. So maybe ganito siya drawing, di ba? And if you find the distance, so ito ay 2.2. Ito ay 0.9. So yung distance na to is basically C plus D. So 0.3 plus D, which is 0.6. Okay. And yung distance na to is C plus D din, which is 0.6 din. Okay. Ito ay 150. Ito ay 150. Okay. So the same dito. And dito. Okay. Then, ano ba yung soil pressure niyan sa ilalim? Di ba ganito yung soil pressure niyan, trapezoidal. So, consider lang natin ito. Ito yung QU max. Di ba ganyan yung soil pressure niya sa ilalim? And if you recall, pag nakuha yung soil pressure sa ilalim, di ba i-multiply lang natin siya, di ba? Okay. So, parang ganito yan. So, ang tanging effective soil pressure dito is this point and this point. Okay. And this point. Okay. So basically, ito yung area na kailangan mo. Tama? Yan. So ito ay 216.43. And itong isa ay 329.43. 0.93. Okay, so let us get the distances. Ito ay, anong distance na ito? That is 0.8 meters. Okay. And this one is 1.4 meters. Okay. So, okay, let's try. So, ganun ulit. Using linear interpolation, get the 0.8 y hat and the 1.4 y hat. Okay. The 0.81 half is equivalent to 257.77 and your 1.4 y hat is 288.66. Okay, hindi ko na siya pinakita because I think alam niyo na yung pagkuha dito. Okay. So 288.66, 257.77. So ito yung mga values dito. Okay. So if you recall, 'di ba sinabi dito, sila yung magpa-punch out, 'di ba? Sila yung magpa-punch out. Yung area na yan yung magpa-punch out. So ang tendency is ito yung foot i-column mo. Okay, yan yung column. Ito yung naiwang part. Then, okay. Then yung pressure mo sa ilalim is trapezoidal. Okay. Yan, trapezoidal. Lakihan ko na siya. Trapezoidal. Okay. Then, itong pressure na to is tama ba na siya yung 288.66. Okay. And itong point na to, siya yung 257.77. Okay. Then, meron kang axial load na PU and meron kang moment na ito yung moment mo na MU. Okay. Okay. Kung naalala nyo sa pag-compute ng punching shear stress, ang ginagawa natin, yung QU natin, minumultiply natin sa area na to. Di ba? Minumultiply natin sa area na yan, then siya yung magiging VU sub P. Okay? This time, hindi natin pwedeng gamitin yung approach na yun because yung area na to sa labas is mahirap computein. Okay? Kasi hindi tayo uniform pressure sa ilalim. Okay? So hindi siya kayang computein. So ang pwede natin gawin is consider natin yung isang part na natanggal. Yung isang part na natanggal is yung nasa loob. Okay, yung other part is yung sa labas, yung pino-compute natin when we are dealing with actually loaded footing. And this time ito namang nasa loob na part yung i-consider natin. Okay. So kapag i-consider natin yung sa loob na part, okay, so to find the VU sub P is basically just take the sum of forces vertical equals 0. Okay. So consider natin tong force diagram na to, so free body diagram. So summation forces vertical. So basically that is Okay. So PU, so VU mo is equals to your PU minus the pressure at the bottom, yung pressure sa ilalim, yung total pressure sa ilalim. So basically that is 288.66 plus 257.77. The height, divide mo by 2, multiplied by the distance 0.6 by 0.6. Okay? So yan yung distance na to. 0.6 dito, itong distance na to, length na to is 0.6. And yung other side is also 0.6. Okay, that is why you have 0.6 by 0.6. And your PU is equivalent to, ano ba yung PU natin kanina? That is the 540.9 kilonewton. Okay. So, solving for VU sub P is equivalent to 442.54. So that is your VU sub P. Then, after getting your VU sub P, so just use the yung how to solve for the actual shear stress. So basically that is tau sub P is equals to VU sub P over the phi BOD. So that is 442.54, okay, times 10 raised to 3. I want to be in Newton, divided by your 0.85. Your BO sub D, so your BO is basically the perimeter. So perimeter niyan is 600 times 4 lang naman, di ba? Perimeter niyan is 600 times 4. Then yung D natin is 300. Therefore, you will arrive 0.723 MPa. Okay? So this will be your answer. Okay. Pwede pa tayo mag-extend class hanggang ano? Tapusin na natin yung sa ano, sa single axis bending. May klase ba kayo after? Hello? Hello? Sige, tapusin ko lang class ha. So for the moments, okay, so for the moments naman, so sa moment, the same dun sa ginawa natin, okay, basically at this time naman, ang critical part is yung the face of the column. Okay. The face of the column, so ito siya. Okay. So yan. So basically kunin lang natin yung distance na yan. Diba ang distance na yan is 0.95. And itong distance na to is 1.25. Okay. So the same dun sa pressure kanina. Okay. Sa pressure diagram. Okay, ito yung inyong pressure na kailangan. And distances are 1.25. So ito ay 216.43. And this one is 329.93. So get the 1.25 y hat. You will arrive to 280.92 kPa. Okay? So after getting yung pressure doon sa 1.25 y hat, so basically the same lang din doon sa sa ginawa natin. Kunin natin yung point load, then multiply mo siya sa the distances. Okay? So that is your MU is equals to okay, so MU mo this time, mahirap na siyang i-solve, di ba? So MU mo this time, kailangan mo siyang hatiin. Because hindi mo kayang unless alam mo yung centroid ng trapezoid. Okay, pwede mong gawin is hatiin mo siya sa P1 and this time hatiin mo siya sa P2. Okay? And therefore, your P1 is multiplied and this distance ito is 0.95. So basically, that is 0.95 over 2. And yung isa is P2 which is 0.95 over 3. Okay. So therefore, kunin mo yung P1 and P2. Okay, your P1 is equivalent to 280.92 multiplied mo by 0.95. Ito yung total length na to. Okay, 0.95 yung length na to. Okay, so 0.95. Okay, then ano yung distance along the length? So away from your screen, that is 0.9. Okay, so multiplied mo by 0.95 over 2 plus your P2 which is equivalent to ano yung distance na to? Okay, yung distance na yan is the 329.93 minus the 280.92. Okay, so ang distance na yan is 49.01. Okay, so multiplied mo by length 0.95. Trapezoid, triangle yan, so times 2. Multiplied mo by the length along your away from your screen which is 0.9 meters. Ito yung distance na yun. Okay. Multiplied by the 0.95 over 3. Therefore, you will arrive to 127.35 kilonewton meter. Okay, so that is your final answer. Okay, so do you have any questions for axial load with bending? Hello guys. Okay. Okay, may question ba kayo?
Sir, ano po coverage ng quiz, sir? Tsaka nung exam po?
Okay, for the coverage of the quiz, I will upload. Okay, I stop sharing. Okay. So for the coverage of the quiz on Friday, I will upload yung remaining part netong module 16 which is yung actually loaded with bending at the both axes. Okay. So ito siya. Okay. I will upload the remaining of actually loaded with footing with axial and bending in both axes. So para wala kayong pasok sa Wednesday and mag-exam kayo on Friday. So kasama yung coverage na to sa Friday exam. Okay. So ano ba yung coverage na hindi natin nasama sa quiz 1 hanggang dito? Yun yung coverage natin. Okay. So any questions?